what I'm about to show you. Right, I want to start by just looking at the tasks that you've been set for this Thursday. And you'll hopefully have opened this already, and if you haven't, then this is kind of your starting place. You will have found, and this was the case when we set tasks for the previous 2 weeks, you've got a main lesson video where I just talk you through the kind of the key points of the lesson. And then you've got all of these tasks to complete all the way down to the last bullet point. And there's the deadline for the 7th of May. Can I just ask some of you to make sure you do hand it in? We had a few people that had completed it, but they hadn't handed it in. They hadn't handed in their virtual note set, which meant we didn't know they'd finished it. So make sure you do that so we know we've got it when you're done. These little YouTube videos have been put in there to help teach you or understand some of the key themes. So don't skip these out. Make sure you watch them as part of the lesson. Okay. If we go into your note set, the first thing you're being asked to do is think about these things called air masses. Now, if I'm just going to do a very quick review about what you've just been doing, you've been looking at basically learning how to kind of describe and explain variations in the weather. And I'm just going to draw you back to the weather maps of the United Kingdom. You were looking at this in the first 2 weeks after Easter. And then we've got a very clear pattern in rainfall, east-west pattern in the United Kingdom, and we've got this kind of much colder region in the north compared to the south of the UK. And the tasks, you had a couple of questions, both worth 4 marks, and they were being marked by me, Mr. Anderson. You'll have had feedback on those too. And we were looking for you to be able to make 4 statements about why, not why it rains, but just describing the pattern, and 4 statements about temperature. And in your statements, you had to have some data like that there. And that's a really basic kind of geography question you get in exams where you're just describing a pattern. And you've already got some experience at how to answer those. If I just move a little bit further on, you then had this key idea of what's causing these variations. So bottom line is, why is it much colder in Scotland? Why is it wetter on the west than the east? And you had to answer this question here. And once again, me and Mr. Anderson were marking that, looking to make sure that you were able to explain as clearly as possible 6 factors that cause the variation in temperature across the UK. And your answer should have related to these 6 factors here. If you didn't have a brilliant answer, you'll have found we gave you a model answer, or we gave most of you the model answer anyway, just so you could see what we would be hoping you'd be writing. And you had to do the same for rainfall. Right, if I just move on to the final bit, which sort of relates to what we're going to be looking at today, you then, because we are at some point this year going to be going to Loch Lomond, although it's more likely to be after the summer holidays, we're starting to build up an understanding of why this area of Scotland, one which we're going to be looking at, has a certain type of weather and how that weather affects people. And this was an exam question. You can see it's worth 6 marks. So we were looking for 6 factors. So for example, because it's very wet, a lot of you were talking about how that might cause flooding. You telling me that colder temperatures might keep tourists away. And those are the kind of ideas that we were looking for you to write about. When you got your virtual jotter back, you'll have seen a model answer was attached to that particular answer to allow you to see what you should have been writing. Right, that brings us to another section of geography altogether. And I just want to start by talking about air masses in general, okay? And in a really simple level, an air mass is an area of the planet where the air has similar properties. And what I mean by properties is it has a similar kind of temperature. So if we look at this map here, the air might be cold, or it might be warm, or it might even be hot. And that's entirely got to do with where that air's come from. And it's really quite simple to understand that any air coming from the top of our planet is going to be cold. Because there's less sunlight getting to the top of our planet. And any air coming from the equator is going to be warm to hot, okay? So that's the first concept, is that it's not just a small area, but a massive area of air. You can see how out in the Atlantic, you've got a huge area of air where all of the air's got a very similar temperature. It doesn't matter where you are. Over here in Russia, all of the air's got a very similar temperature. And then the second thing when we think about the properties of the air is we think about whether that air is wet or dry. And instead of it being to do whether it's coming from the equator or the poles, this time it's to do with whether it's coming from the ocean, and that gives us wet air, and whether it's coming from a continent, like over here in Russia, and that gives us dry air. Because if you're over an ocean, then there's the potential for lots of evaporation to happen, and therefore the air is going to be quite moist. Whereas if you're on the land, a huge continental area like Russia over here or northern Canada over here, then it's gonna there's very little evaporation because it's the land. So what do we call these air masses? Well, just going to scroll a little bit further down. You've got the main 5 in the United Kingdom listed here, and they've all got names, and their names relate to where they have come from. So I'm just going to scroll back up just to talk a little bit about that. So any air mass that comes from an ocean, we call that maritime, like there, okay? And any air mass that comes from the land, we call that continental, okay? The second thing is any air mass that comes from the north, we call that a polar, or sometimes an Arctic, if it's coming actually from the Arctic itself. And if it comes from the south, if it comes from the equator, we call that a tropical air mass, okay? So when we put these two things together, air masses end up having names. They are either polar maritime or polar continental, and they're either tropical maritime or tropical continental. And then there is also the 5th one, the Arctic air masses. Now, I'll just show you this little animation. Sorry, this little graphic. This kind of shows you the main air masses across planet Earth. And you can see I suppose what is the 4 main ones that affect us in the UK. So we've got the CT, which is called the continental tropical or the tropical continental here. And that one originates from the Sahara Desert. That's not what we're getting at the moment. I mean, if you look outside, you will be having nice warm weather, and you've probably got some blue skies wherever you are in Scotland. And I'll talk more about that later on, what's going on there, because that's actually more to do with air pressure. But what we're actually getting in Scotland right now is this continental polar. We're getting this air mass from Northern Europe, from Russia, and it's come across, and it's actually affecting us more in Scotland than it is in England. And because it's this huge, big dry air mass, it's causing high pressure, and it's bringing this really nice kind of clear sky and slightly warmer weather. Although you'll notice that when you're in the shade, it's much colder, and that's still because we are still relatively early in the year. But the key thing here, this big blue one over here and this red one here, what they have in common is they're both continental air masses. Therefore, when they come towards Britain, they're very dry. So in British summer times, when we get those really long, hot summer days for days on end, it tends to be this air mass has come all the way across Europe, across Spain and France, and it sits over the UK. Wintertime, we sometimes get these guys, and when they come over from Siberia, because that's where it originates, they bring this really dry air, but it can actually be brutally cold, especially in wintertime, and that's because there's no cloud covers. And that brings me to another key point, the role of clouds. So clouds are these huge insulators, and if you've got lots of clouds, then the Earth will actually trap more heat. It's a bit like you're pulling a duvet over yourself at night. It will keep you warm. You pull the duvet away, you'll cool down. So when you've got air that's got huge amounts of clouds, it will generally trap heat. But anything coming from an ocean where there's lots of evaporation will bring loads of clouds, and therefore you're going to trap more heat. These air masses, however, they don't bring clouds, they bring clear skies, which means that whilst we might get a lot of heat from the sun during the day, it'll all just disappear really quickly. And if we get them in winter, like this big blue one over here, the polar continental or the continental polar, no matter which way you call it, it brings this brutally cold weather. Okay, so we've got continental air masses that are very dry. Then we've got these maritime air masses, and we've got these two here. So the maritime polar, it comes from this area around Iceland and the kind of North Atlantic. And it brings us lots of rain. It's actually probably, along with its cousin down here, the maritime tropical, these are the two that influence Scotland especially more than any other air mass. And all the rain we get in Scotland is because of these two. In wintertime, this air mass will bring us lots of snow in Scotland. This one can actually bring us snow as well in wintertime. because what it does is, if you follow my arrow, it moves over Russia, then over Norway, and then it has to pass over the North Sea here before it gets to us. And as it passes over the North Sea, it picks up lots of moisture, which, because it's winter, will then fall as snow. Talk more about that in a sec, because there was a little bit on the Beast from the East that we had a couple of years ago, and that was this air mass over here. Okay, right, back to the main worksheet. So you had some questions where you have to just describe, just go down to the actual task, you have to describe and explain the likely weather based on your knowledge of air masses. So you have to have read this page. You need to watch my video, my little lesson tutorial that I put with this. And then you just need to be able to tell me what's the weather like and why is it like that. I've done Canada for you. So if you have a little look at the answer for Canada, Canada is a continent. So we know that should now know that continental air is very dry. So in Canada, the weather is like to be cold because it's a polar air mass. It's also like to be dry because Canada is part of the continent. So it's cold. And the reason for that is it's sitting under a polar air mass, which is cold air. And it's dry because it's a continent, and therefore there's very little evaporation. And you'll actually see, therefore, little water evaporates. So the description in this paragraph is cold and dry. The explanation is as soon as you give me the because statement, which is the reason for that. So we go back to the question. It says describe and explain the likely weather. And you're asked to do all of the places. So Canada's done for you. You've just got to do Iceland, Western Ireland, Turkey, and Russia. Right, quite a simple little task. Shouldn't take you too long to rattle through that. We're then moving on to what the 5 main air masses in the UK are, and these are the most common. The most common that we get are these two over here, because Britain sits next to a massive ocean, and therefore, if you want to know why Britain is so wet, it's because we've got an ocean to our west, and there's a huge amount of evaporation. We occasionally get these two. We've got this one right now sitting over Scotland, which is why we're getting this nice weather today. And the task was, I want to know the origin and the characteristics of each of those 5. I've asked you to use the textbook that you were all given. And I do refer to it in the video. You've actually also on this map, you've got a bit of guidance. You'll notice with some of them that there is a difference in weather between summer and winter, but not all of them. I mean, we, for example, in Scotland, we don't get the tropical continental in winter at all. So therefore, really, when we think about this one, we only think about kind of the hot summer weather we get with this one. It's the only time of year we get this air mass. And you've got to do all 5. One of them has been done for you to show you how to lay it out. Okay. Then there was I gave you a little video link to a news story about the Beast from the East. And this was a polar continental air mass that hit us a couple of years ago. You might remember when the school was closed for a week and we had that huge snow, and then it was cold for quite a few weeks on end. It was like below 0. And that was because we were getting air from Russia. And it passed over the North Sea, picked up loads of snow, dumped all that snow on us, and then the temperature just dropped for weeks on end and the snow didn't melt. And that leads us, once you've read this bit and watched the little video that goes with this task, you're being asked to describe how air masses, when they come for a long period of time, and what we're talking about a long period of time is 2, 3, 4 weeks, when they sit over Britain, don't move, what happens? So when we get this one, and we had this not last summer, but the summer before, we had a tropical continental air mass all summer long in Scotland. This isn't Scotland, obviously, but this is the kind of thing that happens when you get a long period of no rain and hot weather. The question actually says the impact, and this is my kind of top tip for all of you when you're writing your answer, if you've not done this already. The ones I've seen already submitted are always talking about the negatives. And actually, I would say that the impact of something can be positive. So yeah, a lack of rainfall and extremely hot weather does have negative effects on health, on farmers, on water storage areas that dry up, and rivers and so on. But also it's got a huge benefit for the tourist industry, for example. Likewise, this one, tropical maritime air mass, because it tends to bring storms and gales and heavy, heavy rain, lots of negatives, lots of storm damage, lots of flooding. But you think about positives, for example, wind turbines, that would be the upside, plus all of the reservoirs get to fill up over winter if we get this air mass. This air mass can actually bring quite a bit of snow with it if the temperatures do drop. So 10 marks, we're looking for 5 points for each of these air masses. And the word you need to understand is this idea that they arrive and they stay for a long period. So if I just have a little look at this, it's what we call a prolonged period. So just a period of time that's sort of 3 to 4 weeks. Right, now we get to the hard bit. And everything from this week and for the next few weeks is going to be about this, air pressure. Okay. Now, I'm just going to give you a little introduction and show you today's weather forecast and do a little explanation and give you an idea about what you should be writing. And then I'll take some questions, because I'm sure some of you got some questions you want to ask. Right, there are 2 types of air pressure. There is high pressure, and that's exactly what we've got sitting over Scotland right now. And there is low pressure. Now, the simplest way to think of air pressure is think about taking a bicycle pump and inflating a tire. You're pushing air into the tire if you're pumping it up, and therefore the tire is developing high pressure. That means there's more air than there was before because you're pushing more air in. If you let the valve off or you puncture your tire, the air escapes and you've got low pressure. Okay. Now, exactly the same is happening on planet Earth. The only difference is it's air going up or coming down. So when air warms, so for example, what we've got right now in Scotland with heat coming in, as air warms, it's going to rise. And as it rises, if you think about a hot air balloon, for example, when you heat the air in a balloon, the balloon rises. As the air rises, it will condense because it's carrying water vapor and it will turn into clouds. So what happens is on the surface, and that's where you and I are, you end up with low pressure because the air's all going up. So any area where the air's warm and rising, you end up with low pressure and you will tend to get huge amounts of clouds. You'll also get lots of wind in these areas. I'll talk about that in a second, because next to an area of low pressure, you'll normally have an area of high pressure. And the opposite's happening. In high pressure, you've got cooler air and it's therefore coming down, it's sinking, because that's what cold air does, it sinks. So warm air rises, cold air sinks. And when it sinks down towards the surface, where me and you are, you end up with high pressure, which we can see here. Now, because the air's all coming down and you've got high pressure here, it's got to go somewhere. And what it does is it heads towards an area of low pressure. So the air moves from areas of high pressure to areas of low pressure. And that's what you call wind. That's all wind is. It's air moving from an area where the pressure is higher to the area where the pressure is lower. Now, this is really simple to understand, actually, because if you've got go back to my idea of a bicycle tire. If you've got a bicycle tire and you puncture it, the air all comes out of the tire from where the hole is. And the reason it's coming out is there was more pressure in the tire than there was outside. So this is the inside of our tire, and the air's escaping and it's moving towards the outside of the tire because the pressure is lower. Once the pressure inside the tire is equal to the air pressure around that tire, it'll stop deflating. Okay, and it'll equalize. Actually, on planet Earth, though, that never happens. There's always somewhere that's going to be slightly warmer than somewhere else. Therefore, the pressure is going to, the warmer area will end up with lower pressure. There's somewhere that'll be slightly cooler, which will have high pressure, and air will always move between those 2 places. Now, we've got a few other things, and these are the kind of the basic Weather 101 rules of understanding this topic. We call low pressure cyclones. Okay, this is a really important idea to remember. And this page itself is kind of key. You're going to want to refer back to this. You might even, when you're reading it, want to use your highlighter pen on your Google Doc, kind of pick out some key things to remind yourself. So low pressures, cyclones, and high pressure are called anticyclones. But here's something that's even a little bit more confusing. Cyclones are often also called depressions, as in I'm feeling a bit depressed. So anywhere that's got low pressure is often referred to as a depression. And sometimes if it comes from a tropical area, they'll actually call it a tropical depression. And tropical depressions are those things that actually end up becoming hurricanes. So low pressure is a cyclone or a depression, and high pressure is an anticyclone. Now, I'm going to come back to this lesson after lesson over the next few weeks, because these 2 are really important ideas. And the exam board uses these words in their descriptions of weather. When you get asked questions, they might ask you about the weather of an anticyclone. And you'd have to straight away know that an anticyclone is an area of high pressure. Or they might say, what's the weather you'd find with the depression, which is more likely what they're going to say than a cyclone. And you've got to know that means low pressure. Right, so what is the weather? Well, here's a little table that kind of summarizes the key things happening in each pressure area. So let's just review this quickly. Low pressure, your air is rising. It's going up the way. You're going to get loads of clouds forming because air is starting to condense. Water in the air is starting to condense. There's the key word right there, to form clouds. You're going to get winds. It's going to be really quite windy because the air is all traveling to these areas of low pressure. And here's one final bit, and this is always the most confusing bit. People always get these confused. Air travels in an anti-clockwise direction in a big spiral within an area of low pressure. I'll explain more about what that means in a second. But the air is basically traveling like a big, like if you think about a clock with the hour hand ticking away from midnight all the way around, that would be clockwise. Anti-clockwise is opposite of that, obviously. And the winds are actually traveling in this large spiral in an anti-clockwise direction. High pressure, opposite. Your air is sinking. It's coming down. We can see that in the diagram up here. We don't have any clouds. And the reason for that is because the air is coming down, the moisture in the air is sinking rather than rising, and therefore clouds can't form. That's why when you look out your window, you're probably not seeing much in the way of clouds because we've got high pressure right now. You get very little in the way of winds because the wind is moving away from these areas rather than towards, and the wind travels clockwise in these areas. Okay. Now, once you remember you might want to keep referring back to this table and this page when you tackle this first exam question, because this is where it gets a little bit hard. This is where we start looking at these things called synoptic weather charts. Okay, and this is what you see on the weather forecasts. And you can have a look at this one. So I'm just going to show you today's synoptic weather chart for the United Kingdom, and go to the Met Office weather forecast. And here you can see the weather of the UK in terms of where there are sunshine and where it's raining. I want you to just remember down here in a second, because this is the only bit of rain we're seeing down in southwest England. And the rest of the country, you've got nicer weather. We actually have a look at the temperatures. We can see that it's reasonably warm for this time of year. And you can actually see that it's quite warm in this area down here where it's raining, and that's because we've got clouds. Remember what I said about clouds? Wherever you've got clouds, it's going to be slightly warmer because the air gets trapped. If we have a little look at rainfall, we can see the radar picture picking up rain in the southwest of the United Kingdom. But the one I want to show you is this. Okay, now when you first look at these, they look really difficult to understand. But as you start to learn more about these weather maps, you'll start to understand what they're actually showing you about the weather. So we can see this big line, black line, going all the way around Scotland. Okay, now this line is a bit like a contour line, but instead of being called a contour, it's called an isobar. But it does exactly the same thing as a contour line. The only difference is if it was a contour line, it would be showing you the height of the land above sea level. Because it's an air pressure line, it actually shows you the weight of the air. We've got a little number here, 1,024. Generally speaking, if it's above 1,000 or at least above 1,010, we call it high pressure. And if it's below about 1,010, it's starting to fall towards what we call low pressure. So anywhere along this line is 1,024 air pressure. Anywhere within this area is above it. We can actually see in the middle of the North Sea here, we've got the highest air pressure in the area of 1,026. There's probably some weather ship right now outside in the North Sea that's got some recording equipment that is picking that up. If we move down here towards London and Cardiff, we can see another of these lines, 1,020. And that line shows us that's the air pressure in this area. Therefore, everywhere between this line and this line is somewhere between 1,020 and 1,024. Now, remember, why do we need to know air pressure? Because air pressure tells us about the weight of the air. It tells us whether the air is going to be cloudy or not. It also tells us about the way winds are traveling. So let's go to winds. If you remember one thing, I just explained to you that, just going to go back, winds travel in a clockwise direction in areas of high pressure. So if we just jump back to my weather map, what that means is the wind is traveling round this way. round and round. And it actually follows the isobar. These isobars show you the direction of the winds. So right now there is a wind. If I was to follow a wind, maybe put electronic tagging on one little particle of air, which is impossible, but just imagine it in your heads for the moment. I would see it floating following this line all the way around, and it would then change direction and move across the north of Scotland in that direction. And then when it got to the coast of Norway, it would track south. So if I'm in Norway right now, in Oslo, the wind's coming from the north. If I'm in this area of England right here, the sort of central area of England, the wind's coming from the southeast. If I'm in the up here in the Orkney Islands, the wind's coming from the west. Okay. In Edinburgh itself, because this bit of Scotland's right in the centre of this high pressure, you're actually going to find there's almost no wind whatsoever. So these little isolines, or things called isobars, they help us work out the direction the wind is travelling. And in high pressure, we know it comes from a clockwise direction. If we go to an area of low pressure, which we can see down here just off the map, there we go, I'm just going to move it up, down in the middle of the Atlantic Ocean. Now ignore all these little pink lines, that's for next week's lesson, so I don't really want to confuse you too much. These are what we call weather fronts. Down here in the low pressure area, in the middle of the Atlantic, the wind's actually doing the opposite. It is following the line, but this time it's following it against the clock. So it's going around in this direction, anti-clockwise. Okay. So in low pressure, winds travel anti-clockwise. In high pressure, winds travel clockwise. One other thing, just like contour lines, when contour lines are really close together, the land is really steep. When contour lines are really close, far apart, the land is really flat. Well, with air pressure, how close these lines are tells us a little bit about the wind speed. So the closer they are together, like in this area here, I know that the winds are very strong. If I go up here, because they're really far apart, I can tell that the winds are really weak. Okay, so when you read one of these maps, anywhere you can see lots of these lines stacked close together would suggest really strong winds. I'm just going to have a little look across, see if there's anywhere. Oh, if we go over here to the coast of northern Canada, we can see a real area of low pressure. It's 988. That's way below 1,000. The lines are really close together. That means the winds are really strong in this area off the north coast of Canada. You'll be learning more about these things next week. These are weather fronts there. This weather over here will be with us in a couple of days' time when it gets across the Atlantic. Maybe 3-4 days, depends how fast the winds are traveling. But here, winds are traveling in an anti-clockwise direction, and high pressure, just to remind you, clockwise direction. We see another high pressure area of France down here. And imagine if we go over, Russia's got a big low pressure area sitting over it. Right, so air pressure tells us the weight of the air. It tells us the direction the winds are going to be traveling, clockwise or anti-clockwise. It therefore helps us predict what direction they're actually coming from. It tells us how fast the winds are going to be traveling. So high pressure, low, there won't be much in the way of wind. Low pressure, there'll be strong winds. And finally, it tells us whether there's clouds. So we're going to get no clouds up here in Scotland, or very few, because the air is sinking and it's not rising, and therefore there's no evaporation. Over here in the Atlantic, we're going to get loads of clouds because the air is rising and all of that water from the surface of the Atlantic is getting picked up. Think about what I said earlier about the rain in the southwest of England. We can see this little symbol across the southwest of England, and this is what we call a weather front. And it's where two air masses meet. Now, that's all I'm going to say for the moment, because actually next week's lesson focuses on what happens when two air masses meet. What happens when a warm air mass from the south meets a cold one from the north. And I can tell you now, it basically forms rain, but it's the type of rain it forms. It can form steady rain that's got warmer temperatures like this one here, or it can form colder rain and heavy rain like the one shown here by these little blue triangles, or it can do extremely heavy rain like these occluded fronts that we can see here. But once again, I'm just introducing to this idea. That's the main work we're going to do next week. Right, so once you have completed that task, and I'm just about to finish off today's lesson, you will need to read this stuff on air pressure. Everything I just explained to you there in today's lesson is outlined on this little map, just to remind you. I am recording this lesson, obviously, so if you want to watch it back, if you think you've forgotten some things and that you want to note down, I will share this lesson with you. You have However, this question here that we want you to answer, we are going to be marking this question. So you've got to use your knowledge of air pressure from this page and the previous page to tell me to describe the weather in Glasgow and Frankfurt and to explain it. So air pressure will allow you to tell me about the wind's direction, the wind speed, and its cloud cover. Those are the three aspects of the weather that air pressure will allow you to figure out. I've done a little bit of Glasgow to get you started. So Glasgow, the wind direction is from the south. That's the description. And this is because wind travels in an anti-clockwise direction and follows the isobars. So that's the explanation. So you get 2 marks for that. So what is the wind speed in Glasgow and how do you know that? And what is the cloud cover in Glasgow and how do you know whether there's clouds or not? Likewise with Frankfurt, I've given you one bit of a clue that there's no cloud cover, and that's because clouds don't form in areas of high pressure because the air is cold and it's sinking. So that's the explanation. Notice you've used the because statement. Now I want to know about the wind direction. So where is the wind coming from in Frankfurt and how do you know it's coming from that direction? And I also want to know about the wind speed. So if you have a look up there, what's the wind speed in Frankfurt and how do you know it? So if you do the maths on this, you've got 2 descriptions for Glasgow you need to give and 2 explanations, 2 descriptions for Frankfurt and 2 explanations. So there is 8 available marks for this final task if you pick up all of the extra points. Okay, right, I'm going to stop sharing now and gives you a chance to ask questions. So do we have any questions? No one's typed any questions and no one's got their virtual hand up. If you want to ask a question, you can physically put your hand up and I'll invite you to ask your question. I'm just looking across my screen. I'm not seeing huge amounts of you right now. I can see Daniel seems to be dancing on the spot. Archie, you're nodding your head. John's fallen asleep. Rory, your hair's growing in since I last saw you. Yeah, you'll see Rory. He had a shaved head when I bumped into him a couple of weeks ago. We have no questions at all. Oh, Angus, you've raised your hand. On you go. Ask the question, Angus.
Yeah. Why is it called a depression?
That's a really good question. I think it's called, you mean because you would think it would be air pushing down would cause a depression, and that's which is what you get with high pressure, but a depression is low pressure. I've always, normally when I teach this, I just think the best way to remember it is that rainy, horrible weather tends to make us all feel a bit depressed, and therefore low pressure makes us feel a bit depressed, hence a depression. That's not why it's called a depression. There'll be some meteorological reason. And next week, I will research it tonight and find out and answer that question, why it's called a depression. That's a good question. I don't actually know why it's called a depression. We've got a question from somebody, Elise. So how do you differentiate between wind speed and wind direction? That's a good question. How do you know how close do the isobars have to be to know whether it's windy or not? Let me just kind of cast my screen because that's actually a really good question, and I'm just going to show you a way you can answer that. So let me just share the screen again with you all. So if we have a little look here, the easiest way to kind of figure out is the wind strong or not is it high pressure or is it low pressure? If the area, if it's a high pressure like this up here, if the air pressure is above a kind of 1,010, 1,015, then that, first of all, that tells you it's high pressure, and second of all, it's automatically going to tell you that the winds are going to be lower. You never get strong winds in high pressure areas. Winds are always much weaker. And that's because the wind is always moving away from these areas. It's moving to, so right now, the wind in Scotland, in Edinburgh, is moving towards this low pressure area because this is high pressure and this is low pressure. So if you think about my bicycle tire analogy, if you've got an area of high pressure, all the air is escaping and moving to this area of low pressure. So that's actually what would be happening. So if you want to work out wind speeds here, you can automatically say, well, it's low pressure and therefore the winds are going to be stronger. It can be difficult because it depends on the resolution on your weather map. You know, is that far apart or is that close together? And you often need more of a weather map. So here I can see them really close together. therefore, I can tell that compared to this over here, that the wind is less here than it is across here in Canada. I can also compare this to here. I can see, well, the wind's going to be lower here than here. So working out the actual wind speed, you don't know the actual wind speed. I don't know how many miles per hour the wind is in Belfast. What I could say is there is going to be a wind because the isobars are closer together here than they are here, but it's not going to be hugely strong. Second thing I know about Belfast, wind direction. Well, what I need to know there is I need to know the rule that in high pressure, wind travels in a clockwise direction. So if I just follow my arrow around, I can track it around, and I can see that in Belfast, the wind must be coming from down here, which is the southeast, heading to the northwest. If I just maybe go down here, if I go to the north of Spain, so there's a place called Bilbao down here. If I want to know where the wind was coming from in Bilbao, well, wind goes clockwise in high pressure, so it's coming around here, and if Bilbao's here, it's coming from the east. If I do low pressure, let's just find somewhere low pressure. Here we are in Russia. So here's Moscow. So because Moscow's in an area of low pressure, wind is traveling anti-clockwise, so it's following the isobars round in an anti-clockwise direction, and therefore in Moscow, the wind is coming from the south right now. Although you'll notice, even though this is low pressure, the isobars are quite far apart, so the winds aren't very strong. So there's no absolute answer I can give you. How can you tell how strong the wind is? You'd normally have to just sort of, first of all, check, is it high pressure or low pressure? And the general rule is high pressure is weak wind, low pressure is strong wind. And then you just have to kind of look at the isobars and make a judgment compared to other areas of the map. Are they closer or further apart? If I look at your task for this week, we have a look at Glasgow and Frankfurt. You can see the isobars are close together in Glasgow, and in Frankfurt, they're much further apart. So that should help you decide on wind speed comparisons between the two. In wind direction, well, Frankfurt is in high pressure, so we know wind is going clockwise. I've even got some wee arrows to help you remember that. And Glasgow is in low pressure, and therefore wind is traveling anti-clockwise following these isobars. Okay, so I'm just going to stop sharing and see if there are any further questions any of you have asked. I don't have anyone else asking a question at the moment. Okay. Oh, Angus Brown. Yes, on you go.
So, what is a cyclone like the ones that you see in America then? The small scale ones that like rip up houses and stuff.
Right. You mean tornadoes? Yeah. Okay. So this is just names we give things. So a tornado is a very small spiral of air that covers maybe 50 to 100 meters that rotates in a certain direction. They call them tornadoes or twisters or something like that. Cyclone is not an appropriate name for those things, although I know some people in America call them that. Cyclone is the word that we use. They use in Asia, especially in India, to describe what we call hurricanes. So broadly speaking, there are three names for hurricanes. Hurricanes, that's the one we're all used to. That's the kind of things that hit America. Cyclones, that's what they call them in India, and typhoons, which is what they call them in Japan, for example. They're all the same thing. It's just different names for the same thing. What they've all got in common, whether they are typhoons, cyclones, or hurricanes, is they're all extreme areas of low pressure. So if you take low pressure to its absolute limit and you drop the air pressure to under 900, to maybe 850, 880 millibars, millibars are the things we measure air pressure in, then you've got yourself a tropical depression, which can develop into a hurricane. So if I just cast my screen to you guys again, just to show you this, because there is a link with extreme weather here. So if we were in the middle of the autumn, if I was like August, September, and I saw something like this low pressure forming over the Atlantic, I might be a bit worried if I was in the United States, because these low pressure areas can keep dropping, and they can drop to under 1,000, like you see here, and actually they can drop down under 900, which means the air pressure is dropping, and the more it drops, then the more evaporation, because remember, low pressure is created by air rising rapidly. So if the air pressure is dropping, it means there's huge amounts of air rising up really quickly. And as that air rises up super quick, massive clouds will form. The wind will also start spiraling in this anti-clockwise direction, which is how winds travel in hurricanes. And that will keep intensifying. And if that sits over an ocean that's really warm, which in autumn in the Atlantic, it often gets quite warm, especially around the equator, then you get yourself hurricanes. Similar things happen in the Indian Ocean and in the Pacific. So to answer your question, a cyclone is a much larger weather phenomenon. It is actually an area of low pressure, like we're seeing on this map. A tornado, which is the thing I think you were thinking of, is just a small spiral of air. It's generated from a completely different weather phenomenon. It's got nothing in common with what we're looking at here and air pressure. Okay. Any more questions? Okay, guys, if you do have a question you want to hang back to the end of the class, then just don't drop out straight away. Just hold back and I'll answer your question at the end. If you want to email me a question or Mr. Anderson, then do so at any point when you're trying to complete these tasks. We are hoping for them by Thursday at the latest, and you'll get more work next Monday. So keep on track and keep on top of the work would be my recommendation. And I will set up another Google Meet next week. Next week, it gets even a little bit harder, but we are just kind of building you layer by layer, adding on a bit of knowledge every time. So next week is harder, but it might not seem as hard as long as you've focused in on the work that you've done for this week. Okay, so I'll see you all next week and stay safe, everyone.
Big differ, cat sniffer, better MCs will